Okay, so we are doing the set method. Where is it? Way down here. Okay, so I saw a lot of people were, well, a bunch of you used a method called, you said link node e node equals get node index. That's beautiful. And that's fine, as long as it's implemented. So let's, again, using Eclipse, I just go create the method, and happily it creates it for me. But now I have to actually do something. So the first thing, and a bunch of you did this, and I did see some other people who didn't, we really do want to check to see if the index is valid. So I would even defer that to say check index. Because I can call that every place that I have a method that takes an index. Instead of having the same if block repeated, 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 I can implement it in a method and then call that method. I don't expect you to do that on the quizzes because that's a lot of writing. But for your homework, I think it makes sense. And so this is if index is less than 0 or index is greater than. Do I need the equal? Yes, I do, because you can't do something at size because this is a zero-based list.
The list doesn't have to be zero-based if you don't want it to be, right?
It is when you read the definition on the interface. The interface says get 0 returns the first item. So it's a zero-based, even it doesn't matter what implementation you do, it's a zero-based index. Now, if the interface said get, it was 1-based, then it'd be 1-based. Right? But the interface says 0 is the first item in the list. We're computer scientists. We love 0 as our first number to count by. Okay, thank you. Now, in the array list implementation, we could have let the array do this for us, right? We could have just tried to access something out of bounds, and it would have thrown the index out of bounds, etc. But in our implementation, because we're not using an array, we actually have to throw it ourselves. So now that I have check index, I can use check index, and then let's say we could go up here. I can call, right? So now it will throw the exception. Right, so I can put this method everywhere that I need to check the index. So that saves me a little bit of copying and pasting these if statements all over the place. But back to our get node. So now that we know that it's okay, zero, oh, forgot something. What am I going to call it? I could call it current. I could call it return node equals head, right? We always, oops, we start at the beginning, right? And then we say, what are we doing here? We say return node equals node.next. Right, so we're going to go forward index times, and then we'll be pointing at the right node. And then what do we return? Right, so this get method sort of has and node. If I know the index is valid, right? If I know the index is between 0 and size. Well, I don't care about empty nodes. Because the node can have any kind of data inside it, right?
Like if it is empty, you cannot get the value. It returns a null.
If it returns a null.
Like don't you have to check in the for loop, like for I is less than index and the node not included.
I don't have to if I make sure that my size is correct. Right? If the head points to a node, points to a node, points to a node. What does size have to be for this case? It has to be 3. So I don't have any nodes that are null. I don't have a null. The null is after 3. So as long as I correctly keep my list built, I don't have to worry about falling off the end because I won't go beyond the end.
So what if there is no element in the head? In that case, it is null.
So you're saying is null. Size is 0. How often do I go through the loop?
So you have to include that case.
Well, no, wait. How many times do I go through the loop? I equals 0. I is less than 0. 0 is not less than 0. I don't execute the loop. What do I return? Head. And head is null. Right? But now, index, in my check index, that's going to throw an index out of bounds exception because index is not less than size. Right? So I won't even get to that for loop. Is that okay? Oh, the other thing I wanted to say quickly is we're talking about a list. So this is our list. Draw it graphically. Right? This is our list, that thing that contains the linked nodes and the subs. In this array list, read my chicken scratch. In our array list, instead of having the nodes, it has an array and a size. So we create these instances of the things. In the first assignment, all we had was the array, right? And we had to sort it. So what do we sort in the second assignment? We sort this array. What do we sort in the third assignment? The nodes and make sure that the items in the nodes are less than the next item, right? But we have to create, in the second assignment and the third assignment, we have to create our list, and then we have to make sure that the list has things in it when we're doing the testing. if we're doing a doubly linked list where we point to tail, the method add and remove need to move the tail appropriately. But let's say we had a tail. Okay. What method affects tail? Remove if the index is size -1, and the add with no index or the add at size. Right? Because add at size, we're going to put a new node out here, and we have to move tail.
So we actually have to tell tails to move, they won't automatically.
Well, if you add in the middle, tail's still pointing the right thing, you don't need to move it. Right, and for assignment 3, you need a head and a tail. Because when you want to add at the end, you can go to tail and add a new node and move tail. That's a big O of 1 operation versus having to traverse the list to get to the end. So that's a much more efficient add. Okay, back to set. Okay, so I've got the right node. I've got the node that I want to switch its data out of. So, E return value equals node dot data. Right? I return the old value. Oops. So I remember the old value. I should have called it old value. I then set the node's data to the thing that I just set, and I return the old value. Let's do this. What is it? S. No. Escape. Right mouse. I want to refactor, rename. So Eclipse just changed every occurrence of return value to old value, and correctly. So if you want to change memory variables, Eclipse makes it very easy. Let's go on to something I also want to talk about. I want to refactor this. Can I refactor? I'm going to change the name of my test class to definition. Because my list test class, I can say right? And then I could call test2, but I could even be smarter than that to say list 211 test. Oh, it's not this, sorry. So if I have no command line arguments, I'm going to make that test an array list. I'll put a space in there. So what I've done is I'm now using the interface to do my stuff. Now, there'll be a red squiggly in here, right here. Why is that? It's not in the interface. Even though the classes implement it, the interface says you can't access it, so that's an error. You could add it to the interface, but then that's actually not right. I wanted the interface to reflect a list. A list doesn't have the concept of sorting. The list that we implement adds the concept of sorting. So that's a problem, but we could get around that. But the idea would be I can write the test cases and use either of my lists and it will work. So if I did it back the way I had it, no, I want to say oops. LinkedList. Oops. Do that. So now I don't have the red squiggly. If I comment that one and comment that one, I still have the red squiggly. Why do I have the red squiggly? Because I didn't implement the bubble sort methods in this class. But if I did, then I could just change which line is commented out and test both of those implementations. Easy peasy. Questions? That's all I got. Assignment 3 is due on Friday.